Hello everyone, and welcome to Proofs Made Easy. This is a series on YouTube where we're going to teach you everything there is to know about mathematical proofs. We're going to start with the basics, we're going to define what everything is, and we're going to go through tons and tons of examples here. We're going to go through the different steps you're looking for. We're going to give you the best steps to kind of go through for an assignment, for a quiz, and for an exam. These steps will work for all of them so that you can guarantee the most amount of marks possible for them. This is kind of the steps and the procedures you're going to want to take for any type of proof class you do. This doesn't matter if it's linear algebra, doesn't matter if it's combinatorics, doesn't matter if it's a proof course itself. This will carry forward into every single math class you take. So let's begin. Hi, my name is Mac, and I'm going to teach you everything there is to know about proofs. Okay. So in part one of the series, we kind of want to start with the basics of what is a proof. And we're going to do this in three different sections today. We're going to give the background, stuff we need to know before we can define what a proof is, what is a proof, and then finally, we're going to give some examples for these. Okay. First thing we need to talk about is the background. So, in math and in a proof course, the first thing you learn about is something called a mathematical statement. And what this is this is a sentence that is either true or false. Some examples of this are n is an integer, 1 equals 0, the line y equals x plus 1 and y equals negative x plus 1 intersect at 0. Now these are all statements that can be either true or false, depending on which ones. We know, for instance, that the first one is probably true if it's stated as a question and as an assumption. The second statement is blankly false in all scenarios. And the line y equals x plus 1 and y equals negative x plus 1, where it intersects is something we normally have to do a little bit more work in order to figure out whether it is true or false. Not all mathematical statements need to be true or false, obviously. They can sometimes require a bit of work to figure out. So, next is something called an implication. These are the ways that proofs are written 99% of the time. So, given A and B are both statements that can be true or false, an implication is of the form if A, then B. If A, given A is a statement, if A is true, then B is true. This is an implication in itself. These are how proofs are written. So, some examples of these are if x is greater than 2, then x squared has to be greater than 4. That one is a true implication. If f of x is equal to 2x, then f prime of x is 2. This is true as well. If p is an odd number, then p is a prime number. This one is not necessarily true, because this is one you have to actually go through a proof to kind of showcase this is not the case. The third statement I gave in an example is actually not true, because if you were to, for instance, give 9, 9 is an odd number, but it is not prime. It is divisible by 3. So that is an example of a false implication. Okay. With those two out of the way, we can now define what a proof is. Okay. In a lot of textbooks and in a lot of classes, proofs are kind of just jumped into. They're not really described. And the reason for this is they don't have a formal definition to them. But we're going to do our best to describe them here. So, our definition of a mathematical proof is it is a list of techniques and methods in which we use logic, theorems, and other mathematical tools to show an implication is true or false. The reason that we say other mathematical tools in this is proofs can break down into different scenarios. For instance, linear algebra is pure theory, pure theorems, pure definitions, pure step-by-step in order to do them. In combinatorics, when you deal with stuff like graphs and graph theory, they have their own set of proofs that they use. However, all of these are still proofs and they all use the same idea of logic, theorems, and tools that we are given in order to solve these. So let's go through some examples. But first we need to state one more thing. A proof will always have a few things. It will always have an assumption, and it will always have a conclusion. Now, if your proof is written in the form of an implication, if A is your assumption, then B is your conclusion. And it is very important for assignments, quizzes, and exams to get very good at identifying in a question what is the assumption and what is the conclusion. Now we go through some examples. In each of these, I want you to see if you can identify which is the assumption and which is the conclusion. Your time starts now. Let's find out how you did. Okay. Hopefully the first two were pretty straightforward to you. We kind of saw the first one as an example previously that we looked at to basically showcase an implication in general. The second one, we basically had in the assumption there were two specific statements within there, or requirements of the assumption. A had to be odd and B had to be odd. And finally, the third one is that sometimes you will get questions that basically have them flipped. So in this one, it has a very weird wording where n squared is an even integer provided n is an even integer. So again, n squared is an even integer provided n is an even integer. So what I would kind of give as advice and steps to you to do for this is if a question you are given is not given in the traditional form of if A, then B, if something, then something else, just try to think about what is the statement kind of saying. Provided is a good word to say everything after isn't. Another word that is sometimes given for mathematical proofs is given. So basically, in this one, you could have another example where A plus B is odd, given that A is odd and B is odd. That could be another way of rewriting the second one as an example. So again, practice doing those with every single kind of proof question you've got, because what you'll want to do is you'll want to write down both of them first. You want to write down clearly what is the assumption and what is the conclusion. This helps you give you a nice, simple roadmap of everything you are looking at. And with that, we're done. That was part one of our Proofs Made Easy series, just to give you an initial definition of kind of what is a proof, how do you start kind of looking at them. In the second one, we're going to start getting into some more techniques of how do you actually solve them with different types of questions. Again, we're going to keep them very broad for now, but eventually in the series, we are going to break this down into specifics. We're going to do proofs in the sense of linear algebra. We're going to do the proofs in the sense of combinatorics. Thank you very much for watching. I've been Mac, and I will see you in the next series. Bye for now.